Some task is already given to you. Are you prepared? On a very first day, I have told you that whatever I am teaching, you have to prepare it on the same day. Prepared? At least you should have gone through the content. Anyone who can tell me the exact number of formulae that has been there? So again, the teacher is saying the students are different, number of formulas. I have taught to each of you differently. Right? So actually, this is 35. More number of formulas you are handling, it will help you to solve the problems. What you have learned yesterday, the important part, I think that you should learn that you do not use the same formula that you have memorized unless and until you check the condition. If the condition is same, then you can use the formula directly. If condition has changed, you cannot use the formula as given to you. Am I right? This is the first thing. Secondly, I am thankful to the student who had shown me the figures later on, and I was able to understand that it was my mistake that I should have told you how to draw the figures. Am I right? How to draw the figures? Take a pencil, copy it from the board, and you will be able to draw the figure. No, it's not like that. The process of drawing the figure is to be remembered very well. And that's what I was able to observe, that you are not showing the process, you are drawing the figure after I have completed the figure. Am I right? Yesterday's last figure, I have asked you to draw later. Now, in that last figure, what was your process of drawing? The way you started thinking from top to the bottom, bottom to the top, left to the right or right to the left, whatever you felt, you started drawing the figure in that manner. Am I right or wrong? But when I am drawing the figure, I am drawing step by step. You have to remember that steps one after the other. For example, in the last figure that was on the board, which I have corrected also, I have shown that there is a plane mirror M1 and plane mirror M2 inclined at an angle theta. So have I marked theta first or theta last? Last. M1 and M2, na? After drawing M1 and M2 or after completing the whole figure? After M1 and M2. Then I have taken a ray incident, but before that I have drawn a normal at a point where I was going to have the incident ray. After that, it suffered a reflection. While it was suffering the reflection, I have marked angle alpha as well as alpha for the reflection and incident. Then the second ray was incident on a second mirror. Reflected ray was incident on a second mirror. There I have drawn a normal. Then I have considered that angle as beta. Then with the same laws of reflection, I have taken it beta onto the other side, and then we have talked of angle of deviation for the first mirror, for the second mirror, and for the total angle of deviation. This is the process I have adopted. Now, if you are drawing the figure with the same process, it will always help you. But if you are drawing the figure at random, then it will be creating a problem for you. The figures will go wrong. Second important thing, while yesterday you have started drawing the ray diagram, you realized one fact, that even a small change of angle of incidence or reflection, if they are not equal, the extended ray in a backward direction do not appear to coincide. Many students have, what I can say, even though they were not extended backward linearly, they were extended at certain angle, they have shown the arrowhead at that point. That is what my observation is there. So you have to ensure that the angles are equal. If you ensure that the angles are equal, then only it will work for you, right? Otherwise, extension would be creating a problem. That is the reason I have asked you to be present with compass box, where you should be able to make the use of protractor, scale, pencil. Normal should be properly drawn. Normal should be at an angle of 90 degree. If that angle changes, as I was able to show you in one of the figure in the middle, where my angle of incidence, I have taken it as 90, and then it all went wrong. Because later on when I observed it, it was appearing closer to 90 degree, but was not exactly 90 degree. Right? So even a small change of angle would not cause the lines that are extended to form the image to appear properly. Have you got it clearly? Any other question you are having in your mind? How many days are over? Today is the most important day, right? Thursday, I believe that it is the most important day, being a Guruvar, right? Now, I have given some task on a day 1. And I asked you to do something. Writing the questions, very good. So how many questions are written? 40? Show me. No problem. Try to write down the questions as much as you can. And that is the reason I've told you that even if you are copying from someone, it is allowed, no problem. Nobody is going to evaluate whether this has been copied or not. But questions are questions, and you should be able to make large number of questions. Like he has made 34 questions. Before I leave on Sunday, I think he should be able to show me minimum 100 of questions on this particular topic. Whatever come to your mind, that should be entering into the question part. It's so easy. Only you have to raise the question. If you get the answer, it's good. If you don't get the answer, I am there to provide the answer. If I am unable to get the answer, I'll search and get back to you. Right? So please don't forget to write down the questions. And the number is for the formula is 40? 35. Okay, no problem. Now, we'll start with the mirrors, the spherical mirrors. Generate the question, it will work for you. Reflection at curved mirrors. So are you aware of the types of curved mirrors? Concave and? So what do you mean by concave mirror? It's like this, and like this. True, no? But do you know, are you aware that how these concave mirrors are made? Out of a circle? Yes, we are having a complete sphere, and when you cut that sphere in a particular direction, then it gives rise to the concave mirror. Or it is a spherical surface. It all depends upon on what side you are having a coating of mercury done. Accordingly, concave and convex mirrors could be generated. So, a very important part is there about concave mirror and convex mirror. So you are showing me that this is the way it will be appearing from this side as a concave mirror. From this side, it will be a convex mirror. Am I right? The first important thing, you are using sphere, as you have rightly said it. But in addition to the sphere, there is a paraboloid. And paraboloid do form a concave mirror. The advantage of paraboloid mirror are more than the spherical mirrors. Like in a concave mirror, if you are having a different wavelength of light incident, then as per the wavelength, there is a color aberration, or there is a spherical aberration, which we call it. Aberration is actually the point where all the waves are not meeting at the given point. Have you seen that DTH? Are you aware of the term DTH, direct to home? It's not cable. Cable is connected from one place to another. Direct to home is not a connection from home to home. It is called as a dish TV. That is called DTH, direct to home, because actually the satellite sends the signal direct to my home, and it is a communication that could be established through the satellite up in the sky. So it is called direct to home. So it is a dish TV. Have you observed the dish TV? How does it appear? It's a concave but drawn out of a parabola. It's a concave surface drawn out of the parabola, and there is a stick to which a receiver is present at a certain distance. If you measure that, it is the focus of that particular dish, where all the waves are received at that point of a parabola there, and that is why we are having paraboloid or ellipsoid. All types of this can be cut into the concave as well as the convex mirror. Able to get me clearly? Can you define the different parts of the concave and convex mirror? Or actually we will say that we'll have only the concave mirror and we'll try to work on it. Consider that this is the, which mirror? I am asking you purposely because I have not marked anything. This can be anything. If I am putting the marks here, now this has become a concave mirror. Okay? We are drawing some axis. And what is this axis called? So, do you know the spelling of principal? PLE or PAL? Why PLE? So here it is PAL or PLE? Why you are thinking it is PLE? Achha, only school has a principle. Then something you have learned in chemistry also, which you are talking about this term. Principal quantum number. What is the spelling of principal quantum number there? Nobody bothers about it, but it is very important for all of you to understand whether when to write down PLE and when to write down PAL. Am I right or wrong? And probably you are looking at this part for the first time. So when you are writing principal quantum number PAL, it is the college principal. Then? So should I take it as PLE or PAL? Still there is a confusion. Check it out. I am writing directly here. This is known as a principal axis. You can call it the way you want. The reason is this is the most important axis whenever we are looking at the optics. It is such important that if there is a misalignment of this particular axis, or you are not able to put rightly the object on this particular axis, the image will not be formed in the field of view. And that is the reason why we are looking at the most important axis of the ray optics. That is why we call it as a principal axis. Main, head of the institution. The head of the institution look at the teaching staff as well as the non-teaching staff. He looks after the student. He looks after the infrastructure. He looks after the finances of the school. He is the part of each and every section. He is the super boss of the whole institution. Similarly, the principal quantum number can tell you about 18 different physical quantities that are governing the motion of electron inside the atom. A single number is going to tell you about the physical quantities that are involved in the orbital motion of the electron, and that is why it is called as principal. PAL you can call it, principal also you can call it, there is no difference, but it should be PAL. When I say PRI and CIPLE, it means that it is some theory that we are looking at. Some statement is there. Huygens principle, you will be learning about wave optics. So it's a principle that is not demonstrated, that is just directly deducted and used, that we call it as a principle. Able to get this part clearly? So this is the axis which we call it as principal axis. The apex point here, you are calling it as pole, P standing for the pole. Then so you will be having here the point which you are calling it as a focus. Then you are having here center of curvature C. This is standing for center of curvature. Anything else? So, a radius of curvature will be taken from where to where? Center of curvature to the pole. This distance is known as radius of curvature. This is radius. And this distance we are taking it as equal to focal length, that is taken as equal to R by 2. Are you aware of this part? यहां तक आपको पता है? So in this part, one thing is still remaining, that is known as aperture. So anyone who can tell me what is aperture? Correct. So this particular distance is known as the aperture. From here to here, if I draw the line, this is known as aperture. This is the end-to-end distance that is known as aperture here. So you can mention there, aperture in reference to a mirror means the effective diameter of the light reflecting area. Means the effective diameter of a light reflecting area of the mirror. Effective diameter of the light reflecting area. Anything else? So these things are known to you. Any other name for the pole? Because names are extremely important. This is the unique point. You can call it as optical center, or you can call it as vertex. Call it as optical center, or you can also call it as a vertex. So, can you identify which is the concave and convex? I'm not giving you the choice. What is liked by you is not important. How will you identify that? Now, why I'm showing you these two mirrors is very important for you to understand. The amount of concaveness I have shown here is much more greater than the reality. This difference you should be able to understand. Are you able to see the same degree of concaveness? Are you able to see, as you are showing it like this, concaveness? It is almost appearing like this only. And still we are classifying it as a concave or a convex. So I am showing you this particular mirrors for a simple reason, that the amount of concaveness or convexness we are showing while drawing the ray diagram is not the reality. In reality, the mirrors would appear to you in this manner, and you have to decide which one is the concave and which one is the convex. There are rear view mirrors. Have you seen the rear view mirrors attached to the cards? So those rear view mirrors are convex mirrors or concave mirrors? What would happen if you are having a concave rear view mirror? Think about it. We are not starting with the theory, but that is how we have to proceed now. शुरू करते हैं, we will start and then you will understand the importance there. The purpose of showing you this mirror is very clear. The degree of concaveness or convexness which we are showing is not correct. You have to see that concaveness and convexness are not there, almost they are flat. The reason I will tell you, when you say that the focal length of the concave mirror is suppose 50 centimeter, what does that mean? What does that mean? How much will be the radius? 100 centimeter. So you are having a sphere whose radius is taken as 100 centimeter, means 1 meter radius. Now 1 meter radius, if you want to draw for a sphere, it will be almost from this edge to this point. Almost this distance would be 1 meter. 1 meter as a radius, so diameter would be around like this, 2 meter. So this big sphere is there, and we are cutting the small part of it. So it will not have the same amount of concaveness as shown in the figure there. And that is the reason why you should understand how the things are there in reality. Otherwise, we carry the impression that concave is this much amount of concaveness you should have. It cannot have this much amount of concaveness. More is the concaveness, do you understand the meaning of it? The focal length is small. If focal length is small and a small mirror is taken, then it will have more curvature in it. lesser the curvature, radius of curvature is much more bigger, and that is the reason why we are showing this particular differences. So nobody should carry the impression that concaveness in a greater degree, that should not be the picture. It all depends upon the focal length as well as the radius of curvature. Have you got this point clearly? So that is the reason I have shown to you why that is so. Now put down there sign convention. So are you aware of sign convention? Are you aware of sign convention? So what are the sign conventions? Above? Anything else? So just mention the sign convention there. The first sign convention goes in this manner. Just write down. Whenever and wherever possible, whenever and wherever possible, the ray of light is taken to travel from left to right. What is the first sign convention? Whenever you are drawing the ray diagram, see that the rays of light are always traveling from left to right. Can you explain why such convention is there? Can you explain why such convention had been given here? So, if the light is traveling parallel to the x-axis, it will be traveling from negative x-axis to the positive x-axis. So, I will be considering the light traveling in the positive direction of x-axis. So, whenever and wherever possible, you must consider the light ray to be traveling from left to right in accordance with the Cartesian coordinate system. This is the first convention that we will be using it. Cartesian coordinate system means x, y, z axis. Able to get it? Write down the second convention. The distances above the principal axis are taken to be positive, while below it negative. Third convention, along principal axis, distances are measured from the pole distances are taken positive if measured in the direction of light. If measured in the direction of light. Distances are measured negative. Distances are measured negative in the direction opposite to that of the light. In the direction opposite to that of the light. Now, so suppose I am having here the concave mirror. This is the concave mirror we have shown, right? Now I am doing it on the same part, same figure. You have to do it separately once again, right? I have already told you yesterday because I am trying to save my skin, but you cannot. Otherwise you will be getting confused later on. Now, if suppose the light is traveling from left to right, this is the direction of light. This is the direction of light. Then you will be able to measure the distances from the pole. So from pole to the focus, you are traveling in the same direction or in the opposite direction? So focus here will be taken as negative. From pole to the center of curvature, this distance will also be taken as negative. Are you getting it? If suppose you are having the object present here, this is representing the object, then in that case, the height of the object will be taken as positive because it is above the principal axis. Barabar hai? But distance of the object from the pole would be taken as negative. So value of u will be taken as negative here. Are you able to get this part? Whenever and wherever possible, you have to take the light traveling from left to right. That is important because it should be in accordance with the Cartesian coordinate system. Light will be traveling in the positive direction of x-axis. If I consider the other part, what would happen? We'll discuss it little bit later. We'll first try to understand what will be the situation for convex lens, convex mirror. So we will be having here a convex mirror. So this is representing to you the convex mirror. This is representing to you principal axis. The point here, we are calling it as a pole. You will be having focus at this particular point. Center of curvature present here. Suppose you are having the object present here. This is the position of object. Now what would happen? Correct. Height of the object will be taken as positive. So the light should be traveling from left to right. This is direction of light. This is representing direction of light. In that case, the object distance will turn out to be negative. Whereas the focal length will be taken as positive. And the distance from pole to the center of curvature, that will be also taken as positive. Because you are measuring the distances in the direction of light, then it will be taken as positive. If you are measuring the distances opposite to the direction of light, it will be taken as, are you getting it clearly? समझ में आ रहा है? Can I show the object here like this? Can I consider the object here like this? Can I show the object in this manner? If I am showing the object in this manner, the height would be taken as negative. Why height is taken negative here? Below the principal axis, right? Because that is how the Cartesian coordinate system will be working, where you will be able to observe that this is your y-axis. This is representing to you x-axis. So we are considering the light traveling from left to right. This is left to right. This is direction of light. Direction of light. Okay. So light is traveling in the positive direction of x-axis. Are you getting it or not? So if you are measuring from the origin, the distances to the left, it will be negative. If you are measuring from origin in an upward direction, the distances will be positive. If you are moving to the right here, the distances will be taken as positive. If you are moving down, the distances would be taken as negative. So we are looking at Cartesian coordinate system. You can have the distances onto this side negative and onto this side the distance is negative only. Barabar hai ya nahi? So you can check it out that it works with the Cartesian coordinate system. Does it work or not? Any question in the mind? Is it clear? Come on, say something. Okay. Now let us try to break the rule. I personally feel that when we break some rules, we learn a lot. Like there is a traffic signal, there is a red, you should not cross the road. How many of you follow that? If teacher is asking, everyone is following. If friend is asking, are you stopping at the red signal? Like this, you look at. Don't look at back. My point is clear. Let him break the rule and there be an accident and you're spending 6 months in the hospital, unable to walk for a life properly, never he will dare to break the red light rule. Similarly, we have established the convention. Let us try to break it. Able to get me? What would happen? Will we be able to handle it properly? Let's try to work with it. Consider that we are having a concave mirror like this. Is it a concave or a convex? So this is a concave mirror. You are having this as a principal axis. Principal axis. And we are now having the light traveling from. This is the direction of light. Direction of light. It is from right to left. Right to left. This point here, you are calling it as pole. Focus will be somewhere here. Center of curvature will be present here. Now from where we are measuring the distance? So from pole to the focus, you are moving to the right. The distance should be taken as? That is why I have given you this situation. It may be possible that sometime you have to consider the light traveling from right to the left, but you are moving in the direction opposite to that of the light. So when you are moving in the direction opposite to that of the light, you should go for a negative distances. In this case, you are moving in the direction opposite to the light, so focal length is turning out to be negative. So if you say positive, then concave mirror will have a positive focal length. So what is our point of reference? Direction of light is extremely important for us. We will stick to this notation on this particular part of the board. We'll never go for that. But there may be a situation where we will be forced to assume the light to be traveling from right to the left. In that case, again, you are measuring the distance from pole to the focus in the direction opposite to that of the light. So focal length will be taken as negative. The distance from pole to the center of curvature will be taken as negative. If you are having the object present here, object is present here, the height would be taken as positive only because it is above the principal axis. But from pole to this object, whatever distance you will be putting it here, that will be the object distance, that will be still negative. Getting the concept here? Sure? Similarly, we can show here the convex lens, a convex mirror. The direction of light is taken here. It is taken from right to left. Now you will be having the focus here, center of curvature here. So this is representing the pole. This is the line which is representing principal axis. Object is present here. The height of the object will be still taken as positive. Height will be positive. But you will be able to see that you are measuring the distance from pole to the focus. So focal length will be positive. Distance from pole to the center of curvature, that distance is also taken as positive. But you will be able to write down the object distance to be equal to, able to get this part. So can I consider the light to be traveling from right to left or left to right? I can consider both. But what is the problem? You understand, we are all working as a team. And every team member is using different convention, then our figures will not tally, our answers will not tally. The object distance would sometime will appear negative, sometime it will appear positive because of change of convention. So to have a common part of convention so that everyone is able to come to the same answer, we will stick only to this notation. Getting it? But there may be some problem condition in which you will be able to see situation like this, then how that distances are to be measured is to be remembered well. The basic of all this particular part is how the light is traveling and in what direction we are measuring the distances. If we are measuring the distances in the direction of light, take it as positive. If you are measuring the distances opposite to direction of light, then take it as negative. Have you got it? Clear? Sure? Okay. If you want, you can draw the figure accordingly. Now, even if we are changing the direction of light, you can observe for the concave mirror on both the side, here the direction of light is taken from left to right. Am I right? This is the direction I am taking from left to right. Okay? What is the focal length coming out? The focal length is coming out to be negative. Am I right? And in that convention, focal length, negative or positive? Negative. So whether you consider the light to be traveling from left to right or right to left, the focal length of the concave mirror will be always negative. Able to get this part? The object distance in both the cases. Can object distance at any moment of time positive? If it is a virtual object, then only it is positive, otherwise not. But real objects will never have the object distance that will be taken as positive. So whether it is a concave mirror or a convex mirror, always the object distances in this type of problems will be taken as negative only. So one thing is sure, that it will be always taken as negative. Have you got this part? Clear hai yahan tak? Because these are the important part that we are looking at. Ho gaya? Have you finished? Write down. Rules for image formation. Rules for image formation. Rules for image formation. So can you tell me on what basis these rules are to be defined? On what basis these rules are to be defined? Raise. No. What is the basis of rules for image formation? You can add the question. I am myself telling you large number of questions. You are not entering the questions. That is the problem. What is the basis for rules for image formation? Very true. Laws of reflection. This is the basis on which everything has been defined. So what are the laws of reflection? Angle of incidence should be equal to angle of reflection. This is the first thing. Second, incident ray, reflected ray and normal should lie on the same plane. Are you all getting it clearly? So in case of spherical mirrors, where will be a normal? At the pole. You are having a normal. Tangent. So if suppose this is the center of curvature, and I am joining the line from center of curvature to this particular point, then can I call this as a radius? And if I consider a small portion of it, small portion of the convex mirror, then can I say that when a light will be incident along this direction, okay? So your normal will be lying along the direction of radius. Can I say that the normal will be lying along the radius? What is the angle between the radius and tangent to the surface? 90 degree, na? That is known as normal or perpendicular, transverse, right? So if you are having that angle as 90 degree, then at the surface it will be making an angle of 90 degree here. Ye angle 90 degree ka banega na yahan par. So the line joining the point of incidence to the center of curvature will be taken as a normal. Are you able to get me? So normal here is along the radius of curvature. That point is to be remembered. So if you are having here, should I rub it off this part? Because we want to look at the rules of image formation. It is based on laws of reflection. So I'll just remove this part and again redraw the figure. Now, so in what direction I should consider the light to be traveling? It is always to be considered to be traveling from left to right. So for a concave mirror, I will be able to show here this as the mirror. This is the concave mirror with this point as P. This is representing the principal axis. This is representing to you principal axis, okay? And we want to understand the rules for the image formation. We will be able to mark here focus, we will be having center of curvature. Now, if suppose the ray of light is coming parallel to the principal axis, the first thing that you should draw is a line from center of curvature to the point of incidence. Center of curvature to the point of incidence. This is representing the line which is a radius as well as a perpendicular drawn to that particular surface or normal. Then you should be able to mark this as the angle of incidence. With the same angle, you will be able to see that the ray will be traveling along this direction with angle of incidence equal to angle of reflection here and giving you the ray traveling in this direction passing through the focus. Now you can check it out whether it is true or not. Have I measured the angle here? I have not measured it. But if you draw it properly, for example, if you are having a rounder, do you know what is a rounder? Are you all aware of rounder? Yes. So use that rounder to mark a curve of 3 centimeter radius. I am telling you the geometrical part of it. Take out a rounder, set a distance of 3 centimeter and mark a concave mirror of radius of curvature 3 centimeter. Always remember the light should travel from left to right. So you should have a space to the left. Mark the center of curvature. Mark the center of curvature there. Measure the distance from center of curvature to the poles. Divide it by 2. So it will be 1.5 centimeter. That will be representing the focus. Mark the focus. Now you are into the geometrical optics because you are making the use of geometry to get the perfect pictures. Okay? Now draw the ray parallel to the principal axis and make it incident at any point on the concave mirror. Draw the ray parallel to the principal axis and make it incident at any point on a concave mirror. Join the line from center of curvature to the point of incidence. That will be called as normal. Here, draw the reflected ray passing through the focus. Draw the reflected ray passing through the focus. Now, with the help of protractor, check out whether the angle of incidence is equal to angle of reflection. हर एक का एंगल अलग अलग आएगा पर इक्वल आ रहा है या नहीं वो देखना है. आ रहा है 15. So without measuring the correct angle, you are able to get it correctly. So we are drawing the figure as per the laws of reflection only. Everyone should verify whether it is happening or not. I'll repeat the step. I have said that take a rounder, set a distance of 3 centimeter in a rounder, draw the concave mirror, mark the center of curvature, then draw the ray parallel to the principal axis and make it incident at any point on a concave mirror. Then join the line from center of curvature to the point of incidence. Then draw the reflected ray passing through the focus. Mark angle I as well as angle R. Take a protractor and determine the angle of incidence and angle of reflection. You must get it equal. If it is coming out equal, it would mean that you have drawn the figure correctly. If there is a difference of 1 degree, it would mean that some angles or some lines you have not drawn properly, the distances or the focus is not marked properly. Check it out whether it is tallying with the laws of reflection, yes or no. So if you have finished, raise your hand whether you have got it correct or not. If you have got it correct, please raise the hands. By making the use of principle of reversibility, you can see that if the ray of light is incident parallel to the principal axis, reflected ray will be passing through the focus. If the ray of light is passing through the focus incident on a concave mirror, then the reflected ray will be parallel to the principal axis. These are two figures. You can verify in these figures if the distances are properly taken, angle of incidence and angle of reflection will turn out to be equal. Now just two questions more. If the ray of light is incident along the center of curvature, what would happen? It will retrace the same path. Why? So if it is a normal, it should always trace the same path. No. Angle of incidence is equal to 0, angle of reflection is 0. That is the point that you should put it down. Okay? So if it is the ray of light incident along the center of curvature, then you will be having angle of incidence 0, angle of reflection will be 0. So it will retrace the same path in the opposite direction. Okay? And if the ray of light is incident along the directed onto the pole, angle of incidence will be equal to angle of reflection. So there are 4 types of rays which we are looking at. First is the ray parallel to the principal axis. If it is incident parallel to the principal axis, it will pass through the focus. If the ray of light is passing through the focus and is made incident on the concave mirror, parallel to the principal axis. Third one, through the center of curvature, it retraces the same path with the direction opposite. And lastly, if it is made incident on a pole, it will be reflected back with the same angle of incidence as that of the angle of reflection. They are equal. Are you all getting the 4 rays? Now, we'll have a break. After the break, for these 4 rays, you have to draw for the convex mirror and explain how the things are working there. Right? So, convex mirror में आपको shading opposite direction से करना है. बाकी concave mirror के समान ही रहेगा. Think about it and draw the ray diagrams. So, 4 ray diagrams are required after the break. So, just take a break. I think you are having something for you outside. Consume it. And as soon as you consume, start drawing the figures related to these 4 parts. Convex mirror, ray traveling parallel to principal axis, ray traveling towards the focus, through the center of curvature at the pole. This 4 ray diagram I want. Total 8 ray diagrams, you should be able to put it down now. Okay? See you. Bye.